Welcome back, everybody. So this is going to be 7.6. I'll get to the title in just a second. But before we get started, what I want you to do is, without graphing this function, okay, I want you to find these 3 points, or these 3 pieces of information. I want you to find the axis of symmetry, use that to find the vertex, and then tell me what the y-intercept is. I'll give you a minute to do that. So pause this here and find those real quick. All right, so hopefully you remembered from last week that our axis of symmetry can be found using the x equals negative b over 2a expression. So in this case, it's going to be a negative 4 divided by 2 times 1. So our axis of symmetry is actually going to be a 2. Okay, so x equals 2. That didn't show up very well. Hold on. X equals 2. The second thing, we're going to use that value and substitute it in for x and solve for y. So we're going to have a 2 squared minus 4 times 2 minus 5, which is going to simplify to, let's see, 4 minus 8 is negative 4. Negative 4, negative 5 is negative 9. So my vertex is 2 comma negative 9. I believe. I think I did that right. Also, this vertex, because my a value is 1, I know that this is going to be pointing upwards, so it is a minimum value. And the y-intercept is probably the easiest one because you guys know that it's always going to be when the x is 0. So if we substitute 0 for x's, we get a negative 5, which is just the constant. So my y-intercept is 0 comma negative 5. Okay, nice and easy. All right, so let's talk about 2 of the most important points on a graph, especially when we deal with real life scenarios. Okay, our 4 main points when we start applying these concepts to real situations are going to be, let's back up a second, it's going to be the vertex, an important point. Our y-intercept usually tells us where things start from. And then thirdly, our x-intercepts, or our zeros. Okay, very important piece of information as we solve. So let's talk about how we can use the graph to solve its related equation. So let's talk about how to use the zeros to solve graphically first. Okay, first of all, what is a zero? Zero is just the x value that makes it 0, makes the function equal to 0. So we're also going to be using the word roots, okay, in conjunction with this. So if you hear me say a 0 or a root, those are interchangeable. They mean the same thing. It's basically wherever the graph touches the x-axis. Second, our quadratic equations can be solved by graphing the related function. In other words, we're just going to replace y equals, or f of x equals, with 0. So we're just setting the equation or function equal to 0. So for example, if we had an equation here of 2x minus 5 equals negative 3, and we wanted to set this equal to 0, we'd need to add 3 to both sides, and then just replace that 0 with a y equals. So now we have a function of this same equation. If we were to make a table of values for this function, it would look similar to this, and the graph would be identical, right? So notice we have a couple of important points here. We have an x-intercept at negative 1, 0, and 1, 0. We have a vertex at 0, negative 2, which is also the same as our y-intercept. So what would the graph of an equation look like if it only had 1 0, right? So this has 2 zeros, right, here and here. But what would it look like if it only had 1? Well, hopefully you remembered that some of the things we did as we worked with the marble slides. Okay, there were certain things that made it so there was only one intersection point. So let's talk about using these points in a real situation. Although I don't know how real a squirrel holding a chestnut is. But squirrel's holding a chestnut in a tree. He's 46 feet above the ground. So one of the first things I'm going to tell you is that when they tell you where something is in relation to the ground, normally that's your y-intercept. All right, if he drops the chestnut, it lands on top of a bush. Notice it didn't hit the ground, right? It lands on top of a bush. So if I'm drawing a picture of this with my amazing art abilities, we got this little squirrel. He's just, yeah, that's a squirrel. He's got a chestnut. He's dropping it down. He's 46 feet off the ground, right? 46 feet. And it lands in a bush, which is 36 feet below the squirrel. All right, so if it's 36 feet below, what is that in relation to the ground? Because he's not dropping it on the ground. So if it's 36 feet below, that means this is a pretty tall bush, right? It's a 10-foot tall bush. So how do we use this for the information? So we have this function, h of t is negative 16t squared. And just so you guys know, most of these equations, as we move forward, we haven't really talked about it a lot, you're either going to get a negative 16 as an a or a negative 9.8. So you might want to make a note for yourself. If we're talking about feet, gravity falls at, it's like 32 feet per second or something like that. I believe that's what it is. So that's where we get our negative 16. Okay, it's half that value. If we're talking about meters, it's negative 9.8. Okay, so gravity in meters per second would be double that. So that's where that number comes from. You're going to see negative 16 and negative 9.8 a lot. All right. So we have a negative 16t squared plus 46 gives the height in feet of the chestnut as it falls. T is obviously time. When is it going to reach this bush? 36 feet below. So what are we looking for? Well, we have our function, right? H of t, negative 16t squared plus 46. So what, as usual, what is the problem giving us? Well, it's giving us heights. So we don't want to go plugging stuff in for t, that's time. It wants us to solve for time. So what we're going to do is we're going to use the heights they gave us. We know the 46 relates to the starting point, so that's what the c value is. And we also know it dropped 36 feet, but that's not the height we're interested in. We're interested in if this was a parabola, right, which it is, what is the t, the time, at that particular height, at 10? And now we're just solving, all right? So we're trying to figure out that t value. So we can do this a couple different ways. I'm gonna do the short and easy way. So what I'm gonna do is get I don't have a linear term, right? I don't have an x value, just a plain t. I have a t squared and I have a constant. So that means I can subtract 46 from both sides, which will give me negative 36 equals negative 16 t squared. You can divide both sides by, let me get my calculator here. Divide both sides by 16, or rather negative 16. So 36 divided by 16 is 2.25. Probably should have known that. Which means I've got a t squared equal to 2.25. But of course, I need to take the square root of that, right? So square root of both sides to get t by itself is going to be t is equal to plus or minus. Now, I was pretty easy on you guys on the quiz, and some of you on the real scenarios, you included your negative and positive answer. You do not want to include the negative value, all right? So in this case, we've got a plus or minus approximately 1.43 seconds. But I don't care about the negative because time can't be negative. So the answer to this question is approximately 1.43 seconds. Okay, pretty short today. I just wanted to bring together the graphing of the main points with the zeros and how it relates to this. So you're going to be working with a lot of application problems from this point on. All right, so Make sure you take some notes. Make sure you ask some questions, okay? Because we're going to see, I'm going to ask you lots of different things about various ways to apply this concept. All right? See you guys in class.